All right, so it all starts with a question. How do we keep people on our platform for longer? How do we get more ads to be clicked? You name it, whatever it is we go out there and we collect some big data. And with the annotations and the data, we have an AI algorithm. So that data set that you found online, it turns out that it didn't really mean what you thought it meant. Maybe it's not actually fit for the purpose. Maybe it is, and it's just wildly biased because you don't know how it was collected. Maybe when you collected it yourself, there were certain design decisions you had to make that ultimately led it to be incomplete. Those things combined left you with an unfair AI algorithm. What we want to do is we want to come up with ways to characterize that unfairness, to measure it, and best of all, to overcome it, to correct the unfairness in those systems. There are a lot of ways to go about this. There are a lot of ways to define fairness, for example, what we call statistical parity. This is like the hello world of fairness definitions. So statistical parity says that you have two groups in your data. One is the historically privileged group. The other is a historically unprivileged group, a marginalized group. It also says that you have outcomes that you're going to disperse through your classifier. Some of them are positive, some of them are negative. So coming back to Christina's compass example, positive example would be getting bail, a negative would be not. The second on the right is calibration. So calibration looks at predictions at different levels. So again, with the compass example, there's like a 10% chance that this person will recommit a crime. What we do is we look at all of the times the algorithm said it's a 10% chance. A perfectly calibrated algorithm, if we looked at all of those times, 10% would have recommitted. Coming back to why these definitions of fairness are so important is because they can really tell you different stories about your algorithm. So ProPublica, when they did their survey on Compass, when they did their study on Compass, what they did is they were doing the analysis on the right. So they were looking at the distribution of these scores by racial group. And if you look at that, it looks pretty clear that this algorithm is unfair. African Americans are disproportionately being put in the higher violent decile scores. Caucasians are disproportionately being put in the lower ones. What we've been looking into more recently are representational harms. So that's the way the AI system holds or represents certain concepts. And it turns out it can do that in such a way that is harmful to certain groups. And these can be a little more nefarious because we don't always have a resource we have to disperse. And we have to really look into the algorithm to see what's going on there. What types of unfairness is it representing? Common sense is facts about the world that all humans are expected to know. We take the view that this should indeed be facts and not stereotypes or biases in terms of favoritism or prejudice. So here are two examples at the bottom here. So one, fish capable of swimming. Okay, sounds good. But this other one on the right, politician capable of telling lies. Okay, yes, politicians are capable of telling lies, but if we only assign that rule to politicians, that's going to create some bias in the way that the algorithm makes predictions about them in downstream tasks. If you look at the data that is being used to train these algorithms, it is primarily news data, which disproportionately mentions male names. And this is, again, a state-of-the-art algorithm that is failing because it has these biases in the way that it's represented. You know, if you ignore these representational biases, your algorithm will be wrong, right? It's going to make these very trivial, silly mistakes. So it's very important that we have data that adequately represents the problem.